Hi students, good evening. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall estimate population proportion. Estimating population proportion is one of the sections in Inferential Statistics. Please, it is highly recommended that you review the notes in Inferential Statistics. You read the notes in Inferential Statistics. You read the formula. You take note of the formulas. Actually, let me show you what I'm talking about. Let's get on my website. Samuel Chukwu Emeka AppSpot. That is my mobile friendly site. So look at what I'm talking about here. You click on mathematics, statistics, notes. So inferential statistics formulas. Then you can look at estimating population proportion. It is recommended that you review these notes and videos. Then you can view this study guide video, and then you can now work on your assignment. As usual, in this video, we shall just use technology to answer the questions. And that is section 7.2, estimating population proportion. The technologies that we are going to use here are my calculator, the calculator on my website, under statistics resources. You can also get it under portfolio. Under statistics resources, we are going to use the Inferential Statistics calculator. This is what we're going to use here. So we will use this calculator and your Pearson Statcrunch, the Pearson Statcrunch that comes with your my stat lab. So Inferential Statistics is section 7.2. Let's get started. Question 1. A newspaper provided a snapshot illustrating poll results from 1,910 professionals who interviewed job applicants. The illustration showed that 26% of them said the biggest interview turnoff is that the applicant did not make an effort to learn about the job or the company. Wow, that's not good. The margin of error was given as plus minus 3 percentage points. What important feature of the poll was omitted? So this is something that you really have to take note of. If you're gonna work in the media, I'm not gonna be like President Trump, who calls fake news media. Okay, I'm not gonna go into that. Okay, this is politics. It's so sad that very, very sad that the political environment is very different from the academic environment. In the academic environment, we treat everyone with respect. Political environment, you know, a lot of insults, unfortunately. Okay, but what I'm saying is that you have to pay attention to this if you're gonna work in the media, or even if you don't work in the media, but you analyze polls or you do research. Whenever you're doing research, the media, several of them, and I'm not gonna go into name calling, but when you look at the polls, the poll results, okay, and I teach statistics class in traditional also. So we analyze several polls. If you go to the examples that I did, you will see some of what I'm talking about. So actually, I can show it to you. I can, because it's good you probably learn it. So I'm going to go to notes, and I go to estimating population proportion. I think there's an example that I talked about here about news media. Okay, yeah. So news media, they include the margin of error, sample size, results of the poll. Some of them don't include the level of significance or the level of confidence, but they should. So if you ever, this is one of the ones that I saw that actually included the confidence level. Okay, and I'm not gonna call names like I said, but at least you're looking at it. So they include the sample size. This is the sample size here. That's the sample size is included. So it was not omitted. This was the sample size. 1,910 professionals. Then they included the result of the poll, which is 26% of them. They included the margin of error, which is the plus minus 3 percentage points. And this result of the poll, the 26%, you can call it a point estimate. Just read the notes. I talked about point estimate. Okay. I need to get back to my calculator. So they included the sample size, the result of the poll. You can refer that to as point estimate in this question. The margin of error. Now, what they did not include was the confidence level. They did not. They omit it. That was what I said here, right? They omit confidence level or level of significance, but they should do that. They should include it. So if you're working in any news media, or you're doing research, or you're taking surveys, polls, just make sure that when you report the results of your survey, you should state the level of confidence that you used. Okay? You should state that. It's very important. So that's the confidence level that they omitted. Question 2, find a critical value. So what we are going to do here, I will use my calculator first. Then the next question we use Statcrunch. This question after that we use my calculator, and then we go from there. Okay, so let's start with my calculator. That is this. I can actually close this. Okay, so with my calculator, just go to we want to find a critical value. Critical value. So when you click here, this critical value. Go to critical value. I want to actually, use this. Then I can actually drag this here. Okay. Find the critical value corresponding to the confidence level. So these are the critical values, and this means the z-score that corresponds to the area, level of significance divided by 2. So the confidence level is 82%. So you look for the one that you're giving. In this case, you're giving the confidence level, which is 82%. Okay. So the confidence level is 82%. You write 82 and you put percent. Okay. and you just press calculate. So the critical value here is 1.34. That's the answer, 1.34. Enter. All right. Question 3, find a critical value that corresponds to level of significance. In this case, they gave you the level of significance. Question 2, they gave us the level of confidence, or the confidence level. Question 3, they gave us the level of significance, or the significance level. So I'm going to use Statcrunch here. Go to question help, get Statcrunch. I'm going to minimize this. So, minimize it like this. So this is what you do, folks. This is what you're going to do. Go to Stats. You click on Proportion Stats. One sample with summary. Okay? No. I'm sorry. This is just critical value. So, no, that's not what you use. I'm sorry. Go to, because this is critical value, so we're going to use the normal distribution calculator. So go to Stats, go to Calculators, go to Normal Distribution, and critical value is alpha over 2. That corresponds to alpha over 2. Okay? So you first of all, you do this level of significance divided by 2. 0.18 divided by 2 is 0.09. So what you want to do is, and the critical value corresponds to the right, is the score, the z-score that corresponds to an area of 0.09 in the right tail of the distribution. Okay, it is the z-score that corresponds to an area of 0.09, that's 9%, in the right tail of the normal distribution. So I'm going to get this to greater than or equal to, because it's in the right tail. And I'll put this 0.09 here, okay? And I press enter. Yeah, with critical values, it's much better to use my calculator, okay? But you can still use Statcrunch. But if you're using Statcrunch, you're going to use normal distribution calculator. So this still gives us 1.34. 1.34. Now, I want to say something though. If you did this particular question 2 with Statcrunch, this 82%, you have to first of all, because this is confidence level, so you have to first of all subtract from 100 and then you divide by 2 in order to get the critical value. If you're using this particular calculator, okay, the level of significance is 1 minus the level of confidence. So 1 minus 82% is 18%. Then you divide by 2, then you divide by 2, 9%, which is 0.09. That is if you're using Statcrunch. Otherwise, you can just use my calculator and put it in. I hope it makes sense. This is the confidence level, not the significance level. So alpha is the significance level. Okay. So you first of all find, they give you the confidence level. Then if you're using the Statcrunch, because Statcrunch uses significance level. So they give you the confidence level. So you subtract from 1 to get the significance level. So 1 minus 82% will give you 100% minus 82%, which is 18%. That's alpha. Alpha is the significance level. Then you divide by 2. 18% divided by 2 is 9%, which is 0.09. Okay? Then you can now do it to the right, and it gives you 1.34. Okay? Question 4, my turn. My calculator. Question 4 says, express the confidence interval in this form. They gave us the lower confidence limit and the upper confidence limit. Okay, I don't like this number at all. Can I just change this number? I don't like this number. So I'm going to do this and I'll do similar question because I don't like this number. I am a Christian. I don't like this number. So I'm going to, so you're going to go to estimating population proportion. So what I'm going to do now is, let me expand this. I go to estimating population proportion. This is what I need. And let me put it here. Estimating population proportion. You look at what they gave you. They gave us the confidence interval. This is the confidence interval. Okay. So I'm not gonna call it out. Actually, I will I will do this question and then I will do another one. 0.888. I don't like that number at all. Then you press calculate. They want, this is the sample proportion P hat, and this is the margin of error E. Please, all these are in my notes. You go to my notes, Inferential Statistics formulas. It kind of tells you the symbols. See these symbols. Tells you all these symbols. Okay, so you know what I'm talking about. So please, that's why I said it's important you read the notes and the formulas first. Okay, so this is the sample proportion here, 0.777, and the margin of error is 0.111. Okay, but I'm gonna change it because I don't like the number. So I'll do similar question again. So 0.555 is just personal to me. I don't like that number. Then 0.777. Okay. Ooh, wow. Look at the one it gave me. Okay, I'm gonna do this again. I don't like that number at all. 0.111. Okay, I'm gonna change another one. Similar question. Oh, wow. Okay, this one now. So 0.0. I don't also like this number here. I don't know. But anyway, I don't know why it can't change this. Can you imagine this? I hope you guys are not mad at me, right? I hope you don't get mad at me. 0.333. Yeah. Okay, maybe this one should work now. 0.222. Enter. I think this one is a little bit better. A little bit. I don't know why it keeps all this stuff. Okay. All right. Question 5. Statcrunch. Express the confidence interval in this form. One of the ways of confidence interval is actually in this form. So this is already in the form. We have, I think, 2 or 3 ways. We have 3 ways of expressing confidence intervals. So this is one of the forms here. This is one of the forms here. Okay. So this is already in the form. So the answer here is 0.021 and then 0.083. The lower confidence limit and the upper confidence limit. Okay. Question 6, my turn. Although question 5, well, Statcrunch didn't, and that's fine. But question 5 was just putting it in. Question 6, I can, and if you guys want, I can do this one. It doesn't matter. Use the sample data and confidence level given below to complete parts A through D. A research institute poll asked respondents if they felt vulnerable to identity theft. In the poll, the sample size is 937 people, excuse me, and the number of individuals with the specified characteristics is 585 people. The number of individuals who said yes, 585 people. Use a 90% confidence level. Okay, so find the best point estimate of the population proportion. So estimating population proportion, look at what they gave you. They gave us N, they gave us X, and they gave us the confidence level, CL. CL. So if you really go up here, I also put the symbols here. CL is confidence level, CI is confidence interval. Okay, alpha, level of significance. So I also put this in the calculator, so it will be easier for you to look it up. I want you to be familiar with all these terms in statistics. It's important that you are familiar with the symbols, okay, and what they mean. So they gave us X, N, and CL. So we look for that. Now, let us assume in this assignment that all requirements are satisfied. But I also wrote the requirements here. Okay, but let's assume that all the requirements in this homework assignment are satisfied. Because if you're taking this course in a traditional classroom, you will have to, before you start solving, you would have to make sure that the requirements for constructing a confidence interval is satisfied first. Okay, so let's assume that all the requirements are satisfied. So they gave us the confidence level, they gave us the X, number of individuals, and then the sample size. And they want us to find the best point estimate, P hat. So this is the section, this is the part we are going to use right here. So confidence level is 90, put 90%, select percent. Number of individuals is 585. Sample size is 937. Enter. So the sample proportion is the best point estimate of the population proportion. To 3 decimal places, the sample proportion is 0.624. Okay. The margin of error is 0. To 4 decimal places, margin of error would be 0.0260. Okay, do you see that? So with my calculator, I try to really provide details. Okay, that's the nice thing about my calculator. I really try to get the details, both what you were asked and what you were not asked, because if you're taking this course in a traditional classroom, you would need, like for you to find the margin of error, you would need the formula for margin of error. You would need to also find the estimated population of failures. You see that? So if you are taking this course in a traditional classroom, all the details that are needed for you to show your work, I try to provide it in my calculator. Okay? So that's why I also put this estimated population proportion of failures. Okay. So that's the margin of error anyway that you use. So just make sure you select the actual thing that you need. And then the confidence interval, the 90% confidence interval to 3 decimal places. So we have 0.598. That is the lower confidence limit. And then 0.650 upper confidence limit. All right? Write a statement that correctly interprets the confidence interval. So we are 90% confident that this confidence interval contains the actual value of the population proportion. So one has 90% confidence that the sample, it is not A, there is a 90% chance. No, it is not it. B, 90% of sample proportions will fall between that. No, it is not it. C, one has 90% confidence that this interval, confidence interval from the lower bound to the upper bound, or you can say lower confidence limit to the upper confidence limit. You can also say lower bound, upper bound, actually does contain the true value of the population proportion. Yes. Okay. And also on my website, I also have a note on interpreting confidence intervals. Okay. So the answer is C. You are 90% confident that the confidence interval actually contains the actual value of the population proportion. Okay, question 7, Statcrunch. Where is it? There you go. Let me kind of let me see if I can want to see how I can be dragging this. Let me expand this up to here and expand and then get this up to here. Okay. Use the sample data and confidence level given below to complete parts A through D. A research institute poll asked respondents if they acted to annoy a bad driver. A research institute poll asked respondents if they acted to annoy a bad driver. In the poll, the sample size is 2,359, and the number of individuals who said that they honked was 1,159 people. Use a 95% confidence level. All right. Find the best point estimate of the population proportion. I'm not sure Statcrunch will do this one. Statcrunch will construct Statcrunch is gonna construct confidence interval, but the best point estimate, that is this divided by this. I don't think Statcrunch will do it, but let's see. Go to Stat. Okay, go to Stat. Go to Proportion Stats. One sample with summary. Okay, Stat, Proportion Stat. One sample with summary. And you can also do this with your TI-84+. You can. Okay, number of successes in this one is 1159. Number of observations is 2359. And this, by default, is on hypothesis test for the population proportion. We are not doing test of hypothesis in this video. That would be chapter 8. So we would just want to construct confidence interval. And the level is 95%. And you can leave the method as standard word. Okay, leave it as standard word. And just press compute. Okay, yeah, Statcrunch did that. So Statcrunch provided sample proportion. There you go. There you go. It did, I'm sorry. It did. So this is the sample proportion, which is the best point estimate of the population proportion. So you put this 0.491, 0.491 to 3 decimal places. Okay. Margin of error. Okay, margin of error. Margin of error is what, let's do this. Margin of error is what I didn't see here. Okay, so I'm just gonna do this here. I'm gonna do this same question. I'm gonna do this same question here. X is 1159. 1159. And sample size is 2359. And the confidence level is 95%. Confidence level. Calculate. Okay. So this Statcrunch doesn't give you margin of error, as you can see. It didn't give you margin of error. Margin of error is not standard error, no. So Statcrunch doesn't give you the margin of error. It gave you the sample proportion, but it did not give you the margin of error. You see that? So I'm just going to use my calculator. As you can see, the sample proportion is 0.491. Okay, 3098, so 1. Okay, there's the sample proportion. But the margin of error, Statcrunch didn't give it. So I'm just going to use my calculator. Okay, but Statcrunch also gave you the 95% confidence level. As you can see here, this is the 95% confidence level. 0.4711 is the lower bound, and 0.5115, all this is the upper bound. So just take note of that. Just take note of that. So, okay, just take note of that. So the margin of error is 0.0202. That's to 4 decimal places. 0.0202 to 4 decimal places. And the confidence interval, okay, in Statcrunch it is the lower limit. Okay, just close it. Okay, that's fine. In Statcrunch it is the lower limit, lower confidence limit, upper confidence limit, which is the same thing as the lower bound or upper bound and the upper bound. The confidence interval will be 0.471, that's the lower bound, and then 0.511, upper bound. Okay? And we are 95% confident that the interval from the lower bound to the upper bound contains the true value of the population proportion. Okay, we're 95% confident. Question 8, my turn. A clinical trial tests a method designed to increase the probability of conceiving a girl. In the study, 350 babies were born, and 315 of them were girls. Use the sample data to construct a 99% confidence interval estimate of the percentage of girls born. Based on the result, does the method appear to be effective? Okay. Actually, we can, since I use my calculator, I can use Statcrunch here. I can also use my calculator. It doesn't matter. Okay, so here we just use this. This is 99 confidence level. So put confidence level 99%. Number of individuals is 315. And the sample size, X is the number of individuals with the specified characteristics. And the sample size here is 350. Okay, calculate. So the 99% confidence interval to 3 decimal places would be 0.859, that is the lower bound, and then 0.941 upper bound. Okay. Does the method appear to be effective? Yes. The proportion of girls is significantly different from 0.5, 50%. I mean, this tells you that 85.9% to 94.1% with this method, you know, the actual value of the population proportion. And I hope you know proportion can be in fraction or decimal or percentage. So this actually tells you that the actual value of the population proportion using this method resulted in 85.9%, between 85.9% and 94.1% chance is the percentage of girls born, probability of conceiving a girl. Okay, the probability of the percentage of girls born is between 85.9% and 94.1% using this clinical trial. So that's a high percentage. It's more than 50% actually. So yes, it appears to be effective. Okay. Question 9. In the week before and the week after a holiday, there were 12,000 total deaths, and 5,970 of them occurred in the week before the holiday. Construct a 95% confidence interval estimate of the proportion of deaths in the week before the holiday to the total deaths in the week before and the week after the holiday. I'm going to use Statcrunch. How do I get this now? Okay, so this Statcrunch. Bring it here. Actually, move this. So we're gonna go to stats, proportion stats, one sample with summary. Number of successes in this case is 5970. Number of observations is 12,000. And you don't want to, by default, it is performing hypothesis test. You don't want this. You click on confidence interval for the population proportion, and you leave it as 95 because this is 95%, so it's 0.95. You leave it at that. Method is standard word, and you just click compute. So the confidence interval would be, the lower limit is 0.489. Upper confidence limit is 0.506. Okay. Based on the results, does there appear to be any indication that people can temporarily postpone their death to survive the holiday? The answer is no, because the proportion could easily equal 0.5. The interval is not less than 0.5 the week before the holiday. Okay, you see, uh, so the proportion could easily equal 0.5. You look at this confidence interval, and it could easily equal to 0.5. Okay. Uh, the first option, yes, because the proportion could not easily equal 0.5. If you look at this here, it could easily equal 0.5. So uh, you can have this, could not easily equal 0.5. See that? You look at these two bounds, the two limits, lower confidence limit and upper confidence limit, it could easily equal 0.5. So some of these follow-up questions that they ask, you really need to read it and understand it first before you make a selection. Okay, so this is now the proportion could easily equal 0.5. Question 10, my turn. My turn. Let me close this. Just I can put this here. A genetic experiment with peas resulted in one sample of offspring that consisted of 430 green peas and 154 yellow peas. Construct a 95% confidence interval to estimate the percentage of yellow peas. So we have both green peas and yellow peas, but they want us to construct a confidence interval, 95% confidence interval for the percentage of yellow peas. We are going to use this. We're still going to use this. Confidence level, just put 95, okay, percent. Number of individuals, we are just going to focus on the yellow peas. So number of individuals will be 154. Now the sample size, you're going to add this up. Okay, 430 plus 154. 0 plus 4, 4. 3 plus 5, 8. 4 plus 1, 5. So that is 5, 8, 4. Are you guys with me? Are you with me? If you the sample size, because you're not gonna put 430 because that's green pea. This is the whole sample size. Okay, you add 430 plus 154, and that gives you 584. Okay, and the number of individuals with the specified characteristics is 154 because we're focusing on the yellow peas. And you press calculate. So the 95% confidence interval to 3 decimal places will be 0.228 as the lower bound and 0.299 as the upper bound. Okay? Given that the percentage of offspring yellow peas is not 25%, okay. B, it was expected that 25% of the offspring peas would be yellow. It was expected. Given that the percentage of offspring yellow peas is not 25%, do the results contradict expectations? So you look at this confidence interval, we are 95% confident that this interval, that between 22.8% and 29.9% actually contains the true value of the population proportion of the yellow peas. So 25% is inside 0.25 is inside this interval. So do the results contradict expectations? You will say the first option is yes, the confidence interval does not include 0.25. And that is wrong because the confidence interval includes 0.25, as you can see. It is included in this. So the true percentage could not equal 25%. That's not true. Okay, the second option, no, the confidence interval includes 0.25. Yes, as you can see. So the true percentage could easily equal 25%. Yes. Okay. Question 11. An online site presented this question. Would the recent norovirus outbreak deter you from taking a cruise? Among the 34,197 people who responded, 62% answered yes. Use the sample data to construct a 90% confidence interval estimate for the proportion of the population of all people who would respond yes to that question. Does the confidence interval provide a good estimate of the population proportion? Okay. So we're going to use Statcrunch in this case. You go to stats, proportion stats, one sample with summary. Number of successes is 62%. Answered yes. If you look at this question though, you have to be careful. You can't put 62% directly. Like you can put, like you have to find 62% of this. You have to find 62% of this, okay, to now get the number of successes. So you kind of have to be careful with this. Let me do this first with my calculator, okay, and then we can also do it with Statcrunch. But let me first of all do it with my calculator because I have the one that can do it right away. So they gave us the sample size. They gave us the sample proportion. The proportion could either be, can also be a percentage as well. Proportion can be percentage, it can be decimal, it can be fraction. In this case, they gave us the sample size, which is 34,197 people. Then they gave us the sample proportion. They did not give us the number of successes, no. They just gave us the sample proportion. And also they gave us the confidence level. So look for this. As you can see, this is what you're going to use. So they gave you the sample proportion, sample size, and the confidence level. So we're going to use this one. Confidence level here is 90%. 90, you put percent. Sample proportion is 62%. 62. And you select percent. Okay, you select percent. Sample size is 34197. And then you press enter. So the 90% confidence interval to 3 decimal places would be 0.616 as the lower bound and 0.624 as the upper bound. Okay, let me show you how you can do this with Statcrunch. Now with Statcrunch, you just have to be a little bit more careful. You go to stats, proportion stats, one sample with summary. They did not give us number of successes. They did not. So how do we get it? I'm gonna use. Let me get a calculator. Let me get a calculator. So I'm gonna find 62% of this. Okay, so 0.62 times 34,197 equal to. So this is the number of successes here. I don't want to round, so I'm just gonna put it like it is. Actually, it's supposed to be 21203. Okay, because you're dealing with people. But I'm not gonna round. I'll just leave it like it is. Number of let me now minimize this. Number of observations would be 34197. And it is you select confidence interval, and this is 90%, which is 0.9. Okay, 0.9, and you press compute. So this is what it gives you: 0.616 as the lower bound, and then 0.624 as the upper bound. So that is just you just have to be careful, because here to get the number of successes, then you have to do 62% of the sample size. Okay. The next part of the question: does the confidence interval provide a good estimate of the population proportion? In this case, you look at this question here. Let's look at this option. Yes, the sample is large enough to provide a good estimate of the population proportion. No, the responses are not independent. No, the sample is a voluntary sample and might not be representative of the population. Yes, all the assumptions for a confidence interval are satisfied. So I know I mentioned earlier that we assume that the requirements for constructing a confidence interval about a population proportion, that all the requirements are satisfied. One of the requirements is that the sample has to be a simple random sample. You look at this question again. An online site asks the question: would the recent norovirus outbreak deter you from taking a cruise? So you know, when you log on to the internet, to the websites that you visit online, and they ask such questions, right? Some people answer and some people do not answer. So it's a voluntary sample. You know, some people answer. You see the number of people that answered out of 34,197 people. These people answered yes. 21,203 people answered yes. So this is a voluntary sample. Okay, so it might not be a representative of the population because of the when you're taking when you're doing research and you want to construct confidence interval about a population parameter, the sample has to be a simple random sample, not a voluntary sample. Okay, so the answer is C. Question 12. In a poll of 593 human resource professionals, 39.3% said that body piercings and tattoos were big grooming red flags. A. Among the 593 human resource professionals who were surveyed, how many of them said that body piercings and tattoos were big grooming red flags? So I'm happy we still have our calculator here. So this is just 39.3% of this. Okay. So this is 0.393. 39.3% is 0.393. Then times 593 equal to. So round to the nearest integer. Okay, so I'm gonna put this because we cannot be having half human being. I'm gonna put this as 234 people. 234. Okay. Okay. Sometimes, you know, and this is sometimes I have an issue with Pearson. You can't have half human when you're rounding to integer. We can have, if you're, this is human beings. We can't be having, if it's 0.0 something, even if it's 0.001, we have to put it as a human, because we can't have you can't be breaking human beings. So I don't think it's necessary for us to still follow the rounding rule. Yeah, but it appears that is what they used. But if you have this, this is human beings. So once it crosses over, even if you have point something, okay, then you still use that. But probably 233 would work. Okay, you see that? Yeah. So just take note of this. Okay, it's good I brought this up. Just take note of it. If you round it and it, you know, you round up, it doesn't work, then you just round down. But like I said, it depends on the context. This is human beings. All right, I'm gonna minimize this. Construct a 99% confidence interval estimate of the proportion of all human resource professionals believing that body piercings and tattoos are big grooming red flags. Okay, this is my turn to use calculator, my calculator. So they gave us sample proportion, they gave us sample size, and they gave us confidence level. So I'm gonna use this. This is 99 here. Sample proportion is 39.3, and it's in percent. The sample size is 593. Calculate. So the confidence interval, the 99% confidence interval to 3 decimal places would be 0.341 as the lower bound and 0.445 as the upper bound. Okay. Repeat part B using a confidence level of 80%. Okay. I just changed this to 80%. Calculate. 80% confidence interval would be 0.367 as the lower bound and 0.419 as the upper bound. Okay. B, compare the confidence intervals from parts B and C and identify the interval that is wider. Why is it wider? This is what they mean, the width of the confidence intervals. So the 99% confidence interval, the width is upper bound minus lower bound, okay? Upper confidence limit minus lower confidence limit. So for the 99% confidence interval, the width of that interval is 0.445 minus 0.341. That gives us 0.104. So you can kind of write it down. Okay. 0.104. Now, for the 80% confidence level, okay, for the 80% confidence level, the width of the confidence interval would be 0.419 minus 0.367. So you see 0.104 is greater than 0.052. It is. So the 99% confidence level gives a wider confidence interval than the 80% confidence level. Okay? So if you look at these options, 99% confidence level is wider than the 80% confidence level. Okay, as the confidence interval widens, the probability that the confidence interval actually does contain the sample parameter increases. No. When we are constructing, remember this is estimating population parameters. And in this specifically, we are estimating population proportion. So we're using the sample to estimate the population, because having access to the population is difficult. Okay, for most times having access to an entire population is difficult. So we are estimating population parameters. In this case, in this section, we're estimating population proportions. So A is out of the case because it does not, we're not talking about containing sample parameter, no. We use sample statistics to estimate population parameters. So A is out. B, as the confidence interval narrows, the probability that the confidence interval actually does contain the sample parameter. Okay, this mentions sample parameter again. We knock it off? No. We say sample statistics using, sample statistic, not sample statistics. Sample statistic. Okay, remember that's the first sections we talked about. Okay, introduction to statistics. So sample statistic, using it to estimate population parameters. Population parameter. You're using sample statistic to estimate population parameter. So A and B is out. Not sample parameter, no, is out. Now, C, as the confidence interval narrows, the probability that the confidence interval actually does contain the population parameter increases. Well, that is not narrows. Narrows is not it's not the right term for it. It is as the confidence interval widens, then the probability that the confidence interval actually does contain the population parameter increases. So this would be it would be the right choice. So this is 99% confidence level is wider than the 80% confidence level. Okay, enter. Bam. Okay, question 13. Use the data in the table to the right to answer the following questions. Find the sample proportion of candy that are red. Okay, we're gonna use Statcrunch. You know what? Let me minimize this. Oh, how did it go? Okay, there you go. Okay. Let me minimize this. I'm gonna open this up from here. I click to copy table, open in Statcrunch. We're finding the proportion of red candy, which is the number of red candies over the total number of all the candies. That's the proportion. So this is what we're gonna do, okay? Go to Start, go to Summary Stats, go to Columns, click on Columns. Select all these columns, okay? You hold I'm using Mac, so I'm pressing the Command key. I'm holding the Command key down to select the rest. I hold down the Command key to select the rest. Now, if you're using Windows, you will hold the Shift key. Remember, it says select more than one with Shift plus click. That is for Windows users, or Command plus click for Mac users. Okay. I'm a Windows user. I'm a Windows guy actually, but in this, for now I'm using Mac for the meantime. Okay, let's find the number. Otherwise, we have to count this one at a time. So, but let's just find the number. Just click here to find the number. Okay, and then press compute. So we have 8 red candies, 9 blue candies, 7 brown candies, 11 green candies, and 8 yellow candies. So we can add this up. 8 plus 9 is 17. 17 plus 7 is 24. 24 plus 11 is 35. 35 plus 8 is 43. So 8 divided by 43. That's what we need. 8 divided by 43 equal to. So this gives us, to 3 decimal places will be 0.186. Okay. Use that result to construct a 90% confidence interval estimate of the population percentage of candy that are red. Okay. Excuse me. I'm going to. I have 8 candies and I have 43 total candies. Okay. I'm gonna just close this and I'll get my Statcrunch. Oh, where's that Statcrunch? Okay. I'll get the Statcrunch again. Get Statcrunch again. And this is what I'm going to do. I will go to Start, Proportion Stats, one sample with summary. In this case, our successes are the number of red candies, and we have 8 of them. How many candies do we have in all? 43. And we are constructing a 90%, so 0.90 or 0.9. Okay, confidence interval for the population proportion of red candies. Compute. So, this is in percentage. This is in decimal, but they want the answer to be in percentage, and they want it rounded to 1 decimal place. So 1 to 8.8. 8.8% is the lower limit, lower confidence limit. 1 to 28.4% is the upper confidence limit. 28.4%. Okay. Is the result consistent with the 32% rate that is reported by the candy maker? You look at it here, look at this option. Yes, because the confidence interval includes 32%. It does not. Okay. The second one, no, because the confidence interval does not include 32%. That is the correct thing. Okay. Question 14, my turn, my calculator. During a period of 11 years, 2,146 of the people selected for grand jury duty were sampled, and 24% of them were immigrants. Use the sample data to construct a 99% confidence interval estimate of the proportion of grand jury members who were immigrants. Given that among the people eligible for jury duty, 55.7% of them were immigrants, does it appear that the jury selection process was somehow biased against immigrants? Okay, first of all, let's construct a 99% confidence interval estimate of the proportion of grand jury members who were immigrants. They gave us the sample size, 2146. They gave us the sample proportion, 24%. And they gave us the confidence level, 99%. So we're going to use this here. Confidence level is 99%. Sample proportion is 24%. And the sample size is 2146. Calculate. So the 99% confidence interval would be 0.216 as the lower bound and 0.264 as the upper bound. Okay. Does it appear that the jury selection process was somehow biased against immigrants? You look at this here, you only have between 21.6% and 26.4% were the immigrants selected for grand jury. But you have, among all the people eligible for that jury duty, 55.7% of them are immigrants. And you'll have only 21.6%, between 21.6% and 26.4% were actually selected for grand jury. I mean, come on. That means, yes, that is biased, yes. Look, the people eligible for grand jury, 55.7% of them are immigrants. But you only select just, this is the actual, between 21.6% and 26.4% contain the actual proportion of immigrants that participate in, that are grand jury members. Okay. So yes, the confidence interval does not include the true percentage of immigrants. Yes, yes. So it's somehow biased. Yes. Okay. Question 15. Statcrunch. A study of 420,093 cell phone users found that 135 of them developed cancer of the brain or nervous system. Prior to this study of cell phone use, the rate of such cancer was found to be 0.0437% for those not using cell phones. A. Use the sample data to construct a 95% confidence interval estimate of the percentage of cell phone users who develop cancer of the brain or nervous system. So we're going to go to stats. Proportion stats, one sample with summary. The number of successes in this case is 135. Number of observations is 420,093. You select here confidence interval for the population proportion, and we are constructing 95%, 0.95. Compute. They want this in a percentage. this is in decimal, but they want us to give the answer in percentage, 3 decimal places. So I'm going to multiply this by 100 first, 1, 2, then 3 decimal places. This will give me 0.027. 0.027 as the lower bound. Then here, 1, 2, 0.038. 1, 2, 0.038 as the upper bound. 0.038. Okay. Do cell phone users appear to have a rate of cancer of the brain or nervous system that is different from the rate of such cancer among those not using cell phones? So among those not using cell phones, the proportion was 0.0437%. As you can see, this is not included in this for the it is not included in the confidence interval for cell phone users. So let's look at these options. No, because 0.0437 is not included in the confidence interval. Yes, because 0.0437 is not included in the confidence interval. No, because 0.0437 is included in the confidence interval. So C is eliminated. Yes, because 0.0437 is included in the confidence interval. C and D options are eliminated. 0.0437 is outside this confidence interval. Okay, then we look at A and B. Now 0.0437, of course, we know is not included. Now, you go back to this question. Do cell phone users appear to have a rate of cancer of the brain or nervous system that is different? Okay, you see that is different, and 0.0437% is different from these values, and it's also not included in the confidence interval. Yes, they appear to have it that is different, okay, from the rate of such cancer among those not using cell phones. Okay, yes, they appear to have a rate of cancer of the brain or nervous system that is different. Okay. All right. Question 16. My turn. Use the given data to find the minimum sample size required to estimate a population proportion or percentage. So they want us to find the sample size. So they gave us the margin of error, E, and they gave us the confidence level, 90%, CL. So look for where they gave us. So you see that they gave us the confidence level and the margin of error. Okay. Here the sample proportion and the Q hat, the complement of the sample proportion, both of them are unknown. That's fine. So we're going to use this here. They want us to find the sample size. So confidence level is 90%. So I put 90%. Margin of error is 0.01. And when you select this, please select decimal, not percent. Select decimal. Okay? Calculate. So sample size is 6764. 6764. Right? Enter. Okay. Question 17. Statcrunch. Many states, excuse me, many states are carefully considering steps that would help them collect sales taxes on items purchased through the internet. How many randomly selected sales transactions must be surveyed to determine the percentage that transpired over the internet? Assume that we want to be 90% confident that the sample percentage is within 5 percentage points, okay, within 5 percentage points of the true population percentage for all sales transactions. So the margin of error is 5%. That's the margin of error, 5%. And then the confidence level is 90%. We cannot do this with Statcrunch. Statcrunch will not find the sample size for you. I don't think so. Okay, I don't think Statcrunch will find the sample size for you. Statcrunch will construct the confidence interval, but I don't think it will find the sample size. So I'm gonna do this with my calculator. The confidence level is 90%. Margin of error is 5%. So I'm gonna put 5 here. And please, this is not decimal. Okay, this is percent, 5%. Calculate. So the sample size is 271. Okay. Question 18, they ask us sample size. Okay, so I'm just gonna use my calculator. I'm gonna use my calculator to solve this. Margin of error is 6%. Confidence level is 95%. Then it says here, from a prior study, the sample proportion is estimated by the decimal equivalent of 36%. So in this case, they gave us the sample proportion, they gave us the margin of error, and they gave us the confidence level. So you wouldn't use this, you have to use this right here. They gave you the confidence level, sample proportion, margin of error. So you use this. And remember, we just want to find the sample size. Okay. So confidence level is 95. Select percent. Sample proportion is 36%. 36. Select percent. Margin of error is 6 percentage points. So 6%. Calculate. So sample size is 246. 246. Okay. Question 19. Find the sample size needed to estimate the percentage of adults who have consulted fortune tellers. Wow. Use a 0.04 margin of error. Use a confidence level of 95%. And use results from a prior poll suggesting that 17% of adults have consulted fortune tellers. Okay, so confidence level is 95%. Sample proportion in this case is 17%. Margin of error is 0.04. Please don't use percent. This has to be decimal. Okay? Decimal. Calculate. So the sample size is 339. Question 20. A researcher wishes to estimate the proportion of adults who have high-speed internet access. What size sample should be obtained if she wishes the estimate to be within 0.04? So whenever you see within, that's the margin of error. Okay, if you see that within 0.04 with 99% confidence, excuse me, if A, she uses a previous estimate of 0.34, B, she does not use any prior estimates. Okay, so for the A, we're going to use this here. Confidence level is 99%. Sample proportion is 0.34. And you have to change it to decimal, okay? Or you can use 34%. But we are using 0.34. You change it to decimal. Margin of error is 0.04 in decimal. Calculate. So sample size is 931. Okay. B, she does not use any prior estimates. So we're going to use this here, this one here. Confidence level is 99%. Margin of error is 0.04. You change that to decimal. Okay, decimal. Calculate. So in this case, the sample size is 1037. All right. Question 21. A programmer plans to develop a new software system. In planning for the operating system that he will use, he needs to estimate the percentage of computers that use a new operating system. How many computers must be surveyed in order to be 95% confident that his estimate is in error by no more than 2 percentage points? So that means the margin of error is 2 percentage points. Okay, by no more than 2 percentage points. Within 2 percentage points. A, assume that nothing is known about the percentage of computers with operating systems. What will be the sample size? So I'm going to use this. The confidence level in this case is 95%. Okay. And the margin of error is 2%. 2, and you select percent. Okay. Calculate. So this gives us 2401. Okay. B, assume that a recent survey suggests that about 87% of computers use a new operating system. So in this case, I'm going to use this particular one here. Confidence level is 95%. Sample proportion in this case is 87%. Okay. Margin of error is 2%. 2, and you put it in percent. Okay. Calculate. The sample size will be 1087. C, does the additional survey information from Part B have much of an effect on the sample size that is required? Yeah, of course. You see that this is from 2401 to 1087. So, of course, it has an effect. So, A and B, we eliminate them. It says no, no. So, we eliminate them. Option C, yes, using the additional survey information from Part B dramatically increases the sample size. No, it did not increase it. We went from 2401 to 1087. So it did not increase it. D, yes, using the additional survey information from Part B dramatically reduces the sample size. That's right. Yeah. Okay, using this from Part B, it reduced it. Okay. Question 22. The brand manager for a brand of toothpaste must plan a campaign designed to increase brand recognition. He wants to first determine the percentage of adults who have heard of the brand. How many adults must he survey in order to be 80% confident that his estimate is within 5 percentage points of the true population percentage? So this means that the margin of error is 5%. A. Assume that nothing is known about the percentage of adults who have heard of the brand. So we're going to use this one here. Confidence level in this case is 80%. And the margin of error is 5%. Okay. Calculate. So the sample size is 165. B, assume that a recent survey suggests that about 82% of adults have heard of the brand. So we have to use this here. Confidence level is 80%. Sample proportion is 82%. And margin of error is 5%. Calculate. So sample size is 97. C, given that the required sample size is relatively small, could he simply survey the adults at the nearest college? Okay, let's look at this question again. The brand manager for a brand of toothpaste, he must plan a campaign designed to increase brand recognition. He wants to first determine the percentage of adults who have heard of the brand. Okay. So let's look at these options. A, no, a sample of students at the nearest college is a cluster sample, not a simple random sample. So it is very possible that the results would not be representative of the population of adults. B, no, a sample of students at the nearest college is a stratified sample, not a simple random sample. This is not a cluster sample. It is not a stratified sample, no. It is a convenience sample, okay? It's a convenience sample, and it's not a simple random sample. When we did sampling at the beginning of this class, we explained sampling. So this is not a cluster, it's not stratified. It's a convenience sample, not a simple random sample. So it is very possible that the results would not be representative of the population of adults. Okay? So the answer is C. Question 23. A critical value. This is z-score corresponding to area of alpha to the right. Z-score with an area of alpha to its right. Yeah, that's critical value. Okay. Which concept below is not a main idea of estimating a population proportion? Okay, knowing the sample size necessary to estimate a population proportion is important. That is one of the ways. B, we can use a sample proportion to construct a confidence interval to estimate the true value of a population proportion. That is one of the ways, correct? C, the sample proportion is the best point estimate of the population proportion. That is another way, correct? D, using a sample statistic to estimate the population proportion is utilizing descriptive statistics. Oh no, that's not it. 25, question 25. Which of the following groups has terms that can be used interchangeably with the others? Percentage probability proportion, yes. Critical value probability, no. Critical value percent, no. Critical value percent, no. Percentage probability proportion is the correct answer. A dash is a single value used to estimate a population parameter. Approximate a population parameter. That's a point estimate. Okay. If you these are in my notes. It's on the notes. Question 27. Which of the following is not true of the confidence level of a confidence interval? A, the confidence level is also called the degree of confidence. Yes, 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 yes. Did I put it here? You see that? Confidence level or level of confidence or degree of confidence or confidence coefficient. See that? So A is true. You see that? I try to, see everything that can be called that. See, a confidence interval is also known as interval estimate. Okay. I think there's another one about the lower confidence limit, upper confidence limit. Okay. So A is eliminated. It's not it. B, the confidence level gives us the success rate of the procedure used to construct the confidence interval. That is correct. C, there is a 1 minus level of significant chance where alpha is the complement of the confidence level that the true value of the population proportion, P, will fall in the confidence interval produced from a sample. Okay, my only concern is we are 95, we are confident. We don't say 1 minus, I know 1 minus alpha is the confidence level, but we don't say it as chance. We don't say it like that, no. So let's look at D though. D, the confidence level is often expressed as the probability or area 1 minus the significance level. Okay, where alpha is the complement of the confidence level. That is the significance level. So the answer is C. We don't say one, there is 1 minus alpha chance. We don't say that. No. Okay. We say we are 90% confident, 95% confident, 99% confident that confidence interval actually contains the true value of the population parameter. Okay, population parameter could be population proportion or population mean or population standard deviation. Okay. Question 28. Which of the following is not an observation about critical values? A critical value is the area in the right tail region of the standard normal curve. Okay, that's right. B, well, a critical value is not the area. No. Critical value is the z-score corresponding to the area in the right tail region. So it's not an area. It's the score corresponding to the area, okay, in the right tail. B, a critical value. So A is wrong. A is not an observation about critical values. But let's look at the other options. B, a critical value is the number on the borderline separating sample statistics that are likely to occur from those that are unlikely to occur. That is correct. C, the number Z subscript alpha over 2 is a critical value that is a z-score with the property that it separates an area of alpha over 2 in the right tail of the standard normal distribution. That is correct. D, the number Z subscript alpha over 2 is a critical value that corresponds to an area of 1 minus alpha over 2 to its left. So, you look at this, the correct option would be A, okay? That's the correct option. Is the z-score corresponding to the area in the right tail. Okay. Question 29. Which of the following is not a requirement for constructing a confidence interval for estimating the population proportion? I think I listed the requirements here. In the notes, I listed the requirements, and I also listed some requirements in these. But in the notes, I listed the requirements. There are at least 5 successes and 5 failures. That is right. Sample is a simple random sample. Correct. Fixed number of trials. Correct. Trials are done without replacement. No. Okay. Question 30. When analyzing polls, which of the following is not a consideration? A. The confidence level should be provided. B. Which is correct. B. The quality of the poll results usually depends on the sampling method and the size of the sample, but not the size of the population. That is correct. C. The sample size should be provided. Correct. D. The sample should be a voluntary response or convenience sample. No, we don't want that. Okay, we don't want that. We want a simple random sample. The last but not the least, which of the following is not needed to determine the minimum sample size required to estimate a population proportion? If you look at the formulas, I think I gave the formulas for this, for sample size is in the notes. The level of significance, we need it. Standard deviation, we do not. The critical value, we do. Margin of error, we do. If you look at if you go to the notes, Inferential Statistics formulas, okay? I gave you formulas estimating population proportion, then formula for the sample size. See that? You need alpha over 2. You need the critical value. There's nothing that says standard deviation here. So the answer is this. Okay. All right, folks. You just click save. Thank you so much for listening to this video presentation. Please watch out for other videos. If you have any questions, please ask. And you have a good night.